Right, there are two methods of calculating a rate of reaction and investigating a rate of reaction. There's the continuous method, but here we're going to have a look at what we call a clock method. And from GCSE, you'll be familiar with this because it is the sodium thiosulfate experiment that you will have done as a core practical. So we're going to have a look at how this works and how it can work for a number of different investigations. So really basic setup here. This would be equipment that could be used for both continuous and clock method. However, if we are using the clock method, what we are going to do is we are going to time how long it takes for a set volume, let's say the whole measuring cylinder, to be filled with air or gas. So as a result, this is going to give you a set time, and you would change either the mass, surface area, or the concentration of the acid, or the mass of the magnesium, or the surface area of the magnesium, to see its effect on rate. And what you would do here is you would mix them together and then, let's say, time how long it took to empty the measuring cylinder. Once you've got that, you've then got a number of different times to perform the same task. So you need to be aware of the different control variables, such as the volume of gas that you're producing, for example, and volumes of acid and that sort of stuff. But you would need to change one thing, such as the concentration. Now, sodium thiosulfate one is the one that you probably recognise from GCSE. You've got a number of different beakers. Each of them have got a cross underneath. In there, you've got different concentrations of sodium thiosulfate. So this is what is pre-mixed. You have to mix it as. So this is all sodium thiosulfate. This is 10 centimeters cubed of thiosulfate and 40 centimeters cubed of water over here. So this is the lowest concentration to the highest concentration. When you mix it with acid, it goes cloudy. It forms a sulfur precipitate. That sulfur precipitate blocks out the cross, and once you cannot see the cross, you stop the stop clock. So you will start them all at the same time and wait for the cross to disappear. You don't have to start them, you can do them individually, but once you mix them together, once you mix the acid and the sodium thiosulfate together, you'll start the stop clock. Once the cross is disappeared, you would stop the stop clock, and then you would record the amount of time it took to make the cross disappear. And it should take longer as the concentration decreases. Now, there are a number of issues with this method that you can go into in terms of sort of objectiveness and eyesight and all sorts of things. But we're not going to look at it here, because what we're looking at here is the method. So it is for a specific point in time. You're measuring the time it takes to get to that change in the equipment and the chemicals. Another one you might be familiar with, just to run through it, is the amylase practical you did in biology. So this does work in biology. In fact, most biological rates are measured using the clock method. And you'll hopefully remember you've got some amylase and some starch. The starch turns iodine black or a very dark blue. So, however, iodine is a yellowy colour, an orangey yellowy colour like this. And you start the stop clock over here, mix these together, and every sort of 10 seconds you will place some of the solution or mix some of the solution, the iodine solution, with the mixture of amylase and starch, and you'll see if the starch has gone. And then the amount of time it takes for that iodine to go yellow or an orangey yellow is the time it takes to remove all the starch. So that's the end point. When you do this calculation, it's a little bit different, because you won't be plotting it on a graph as a curve. What you will have to do is you'll have to do rate, which is 1 over time. And normally that gives a very, very small decimal number. When you put this into a graph, you need to make sure your axes are equally or equidistant. So your concentration goes up like that, and your 1 over time goes on the x-axis. And what you should find is that the rate increases as such.